Welcome to another Mathnificent Conversation featuring adding and subtracting rational expressions with unlike denominators. The quick way is your nerdy math bestie Lex. Grab your pencils and let's go. A little background information before we get started, which I like to call mint green tea. Same as with fractions, we're going to do our crisscross and across method. So if I want to add a over b or subtract c over d, we multiply a times d, that's what's Chris, plus or minus multiply c times b, that's cross, all over multiply b times d. Few things you should know. You should master finding a common denominator before mastering the cheat code because it should only be used when it makes sense. Now let's go through a few examples. We're going to start off with adding 3 over x plus 4. First thing I want to note, always make a whole number into a fraction by putting it over 1. That way you know what you're dealing with. We're dealing with two fractions that have different denominators. So let's go ahead. 3 times 1 plus 4 times x all over x times 1. That leaves us with 3 plus 4x all over x. 3 plus 4x is prime. It cannot be factored further. So I can't simplify the numerator and the denominator. So my answer is complete. All right, 7 over x minus 1 minus 5 over x plus 2. So let's start with Chris. That's going to give us 7 times x plus 2 minus cross. Remember, anytime we write a minus, we follow it up with a parenthesis, so we remember to distribute it. 5 times x minus 1 all over. Remember, we leave denominators in factored form. X minus 1 times x plus 2. Let's go ahead and simplify the numerator. 7x plus 14 minus 5x plus 5 all over. Keep the denominator in factored form. 7x minus 5x is 2x. And 14 plus 5 is 19. All over x minus 1, x plus 2. 2x plus 19 is prime. It cannot be factored further. So I can't simplify anything in the numerator with anything in the denominator. So our answer is complete. Next up, 5 over x plus 1 over x minus 2. Two fractions that need to be added, different denominators. Let's go ahead and crisscross and across it. We start off with 5 times x minus 2 plus 1 times x all over x times x minus 2, leaving it in factored form. Simplifying the numerator, we get 5x minus 10 plus x all over x times x minus 2. 5x and x are like terms, and they combine to 6x minus 10 all over x times x minus 2. In the numerator, 6x and 10 have a common factor of 2. So I can factor a 2 out, and we're left with 3x minus 5 all over x times x minus 2. The numerator and denominator do not have any common factors, so nothing simplifies to 1, so our answer is complete. Okay, next up we have one that's a little more complex, so we'll try to take it slow. Two fractions that need to be subtracted, different denominators. Let's go ahead and crisscross across it. So Chris is going to be x minus 3 times x plus 2 minus, every time we write a minus, we follow up with the parenthesis, x times x plus 1 all over x plus 1 times x plus 2, which we keep in factored form. X minus 3 times x plus 2. Remember, we have to FOIL that out or distribute that out, whichever you call it. That's going to give us x squared minus x minus 6 minus, I'm going to keep following this up with the parenthesis until I simplify it. That's x squared plus x all over x plus 1, x plus 2. Now I can go ahead and distribute this negative. So x squared minus x minus 6 minus x squared minus x all over x plus 1, x plus 2. Okay, and my numerator, x squared and negative x squared are like terms, and they equal 0. X squared minus x squared is 0. Negative x and negative x is negative 2x. And then negative 6 doesn't have anything to combine. All over x plus 1, x plus 2. In my numerator, both terms have a common factor of negative 2. And I'm left with x plus 3 all over x plus 1, x plus 2. I don't have any common factors between my numerator and my denominator, so my answer is complete. You should not use the quick method if the denominators have a common factor, because you're going to overcomplicate the problem. So I'm going to simplify this problem two different ways. I'm going to show you how the quick way actually becomes the long way if you don't notice the common factor between the two denominators. Okay, on the left, we're going to go ahead and crisscross and across it. So we end up with 3x times x minus 1 minus, we always follow up a minus with a parenthesis, 5 times x squared minus 1 all over x squared minus 1 times x minus 1. Okay, at the top, we end up with 3x squared minus 3x minus the quantity 5x squared minus 5 all over x squared minus 1 times x minus 1. Okay, so that's 3x squared minus 3x minus 5x squared plus 5 all over x squared minus 1 times x minus 1. Okay, 3x squared minus 5x squared is negative 2x squared. Negative 3x doesn't have anything to combine, nor does positive 5 all over x squared minus 1, x minus 1. Okay, remember we don't like our leading term negative, so we factor out a negative 1. And that leaves us with 2x squared plus 3x minus 5. Well, that leaves us with a quadratic trinomial, and we know we always have to factor that, or at least see if it factors. And in fact, it does. If you need to know how it factors, you can go to the quadratic trinomial videos and watch that. So we have negative 1 and it factors into x minus 1, 2x minus 5. So you've had to do the side work and factor the numerator. X squared minus 1, x minus 1. Okay, now the numerator and denominator have a common factor of x minus 1. We can simplify that to 1. So now we're left with negative 1, 2x minus 5, all over x squared minus 1. Remember, we can't leave anything not factored unless it's prime, and it can't factor. So we have to go ahead and factor the denominator to make sure nothing simplifies. 2x minus 5 all over x squared minus 1 is a difference of two squares. It factors to x minus 1, x plus 1. I don't have any common factors. Now, normally when I simplify something to 1, I would say acknowledging x can't equal 1, but because we still have that x minus 1 in the denominator, I don't have to acknowledge it because it's acknowledged in the denominator. Now, on the other side, let's assume we've been doing our work the way we should be. We're noticing things that factor. We're noticing difference of two squares. We're noticing difference of cubes. We're noticing quadratic trinomials. We would notice that x squared minus 1 is a difference of two squares. So it factors to x plus 1, x minus 1. So then we would notice that this fraction only needs x plus 1, and we know we can only multiply by a form of 1. So we multiply by x plus 1 over x plus 1. So that gives us 3x over x plus 1, x minus 1, minus 5x plus 5, all over x plus 1, x minus 1. Okay, now I have common denominator, so I can subtract straight across, remembering that this subtraction has to distribute. So 3x minus 5x minus 5, all over x plus 1, x minus 1, which is just negative 2x minus 5 over x plus 1, x minus 1. We don't like to leave a leading term negative, so we'll go ahead and factor out that negative 1. And we are finished. So you should see that finding a common denominator when the denominators have a common factor is a far more flawless method than crisscrossing across when the denominators have a common factor. Over here, this is what I like to call Turks and chaos, because we've created more work than what was necessary. So make sure you know when it's appropriate to go ahead and crisscross and across, and when you should just see that common denominator and go ahead. When they have a common factor, use the common denominator method. If they don't have common factors, go ahead and crisscross and across it. Hope this video was helpful. Remember, you're magnificent and you're brilliant, and I'll see you in our next video.